Hello and welcome to part 5 of Physics Paper 1. So I'll start straight away because it's part 5. So let's have a look at this question. So number 9 we're up to now. A student investigates the relationship between force and acceleration for a trolley on a runway. Figure 12 shows some of the apparatus the student uses. So we've got a trolley, so it's just like a little thing on wheels, like a little car thing, card, runway, light gate. So a light gate is a piece of electronic equipment that when the card goes through it, it sends a signal, okay, to a reader. Okay, so it either sort of stops a timer, okay, it starts and stops it. So it will tell us which one we're dealing with in a minute. Runway, so just like for it to run along. Bench, just like a table, and a weight hanger. Let's have a look at what it's asking us then. Number 1, describe how the student could increase the accelerating force applied to the trolley. Okay, so there's no motor on it or anything. What's happening? This thing's called a pulley, so it's like a little wheel, and the weight's going down. But when you get weights on the clock, you've seen the weights on the clock, like my grandfather clock. So what it's doing is the weight's putting it down. Okay, that's 2 marks. So all you have to do in this is very, very simple. You add, oh, I need to put my pen tool on. So add masses to the hanger. So add masses. You could put weight. Okay, add masses to the weight hanger. Okay, so that's that one. Describe how the mass of the moving system can be kept constant. It's quite a tricky way of asking it. Okay, so describe how the mass of the moving system, so how the mass, underline that, how the mass can be kept constant. Okay, so if you want to accelerate, what I say, accelerating without adding that, keep the mass of the system constant without actually adding it sort of overall. So what you were saying was, okay, is that if you put mass here, you need to take it off there. So the answer to that would be transfer mass, okay, between weight and, sorry, transfer masses between trolley and hanger. We'll transfer mass or masses, so masses or mass between trolley and hanger. They also accept weights as well there. Okay. So yeah, we can get a bit of a longer question, I think, here. Explain how the student could improve the procedure to compensate for the effects of frictional forces on the trolley. So compensate frictional forces on the trolley. So obviously anything that runs along a runway or the bench is going to undergo frictional forces because anything on a surface will. Okay, so what you could do, okay, is actually raise one end of the runway so it runs downhill. So raise one end of the runway. Tongue twister, isn't it? One end of the runway. Okay. So yeah, this is, I remember I did some classes. It's actually quite tricky to do this in. So you raise one end first of all, so that the trolley runs at a constant speed. So it just starts to move. Okay. So trolley starts to move. Okay. Because gravity will compensate for friction. You might have done this in class. You raise one end first of all, so that gravity compensates for friction, so it overcomes it. Okay. Let's do the next thing. 9B, a bit of a longer one, 6 marks. That's a longer question. Figure 13 shows two objects, Q and R, before and after they collide. So Q is a bigger object, colliding with R. So it could be like two balls on a table. And afterwards, they both go in the same direction. The arrows show the direction of the objects. The arrows are not to scale. So that means that if someone's got a bigger arrow, doesn't mean it's going faster in this case. We've been told that. Explain how momentum is conserved in the collision and use Newton's third law and Newton's second law in your answer. Newton's second law can be written as force equals change in momentum over time. Okay, so how momentum is conserved. Let's see what momentum is first of all. Okay, momentum, okay, is mass times velocity. Okay. So sometimes it's written as an equation, P equals M times V. Okay, so we're talking about Newton's second law as well. So the other thing is there's equal and opposite reactions. So equal and opposite reactions. Okay, opposite reactions. Okay, so next one is so the change in momentum of Q has to equal the change in momentum. So change in overall momentum is actually 0. Let me just write this out. As okay, so momentum before has to equal momentum afterwards. So momentum before equals momentum afterwards. Okay, so what would that be? It would be this is what it's in an easier way. So let's have a look which one was actually stationary. So R was stationary before, so R has to accelerate afterwards. So R was stationary or static, it means it's not moving as well. So R accelerates afterwards. Okay. As Q transferred momentum when colliding. Okay, so before, okay, so we had Q was moving, so Q, okay, so we're going to write the mass Q times velocity Q plus so mass, we'll go in the same order, mass R plus velocity R. Right, so this, because velocity, because it was stationary, that's actually 0. Okay, 0 equals, I'm going to write a bit shorter, so MQ for mass plus VQ, okay, so times MQ times VQ plus MR plus VR. Okay, so that's actually how you write conservation before and after. Okay, so that's what would have happened. We don't know the numbers, so we can only write that. Okay, so let's look at carefully about collisions. Okay, so getting on to fusion and fission. So it says fusion and fission are nuclear reactions in which large amounts of energy are released. In a fusion reaction, two hydrogen nuclei are forced together to form a helium nucleus. Explain why a very high temperature is needed for this to happen. So two hydrogen nuclei. You remember what hydrogen nuclei are? They are protons. Okay, and they both have positive charge. So hydrogen nuclei are protons. Okay, they are positively charged and they repel each other. Okay, so okay, the high temperature temperatures are needed to give the nuclei enough energy to overcome the repulsion. Okay, so that's actually it, to be honest. So we've got high temperature, high energy to get over repulsion. Okay, let's have a look at the next thing. In a fusion reaction, the combined mass of the two small nuclei is greater than the mass of the resulting nucleus. This decrease in mass m appears as energy E according to the equation. E equals mc squared. That's a famous equation, isn't it? C is the speed of light. The energy released in one fusion reaction is 4.5 times 10 to the minus 12 joules. So, each reaction is actually a very small amount of energy. Calculate a decrease in mass. Okay, so let's have a look. So all we need to do is substitute into this equation. So energy, remember, energy is always in joules. So if we see joules, that J, it means it's energy. 10 to the minus 12, okay, equals m, which you don't know, times 3 times 10 to the power of 8, that's the speed of light, squared. Okay, so then you would have to rearrange this, actually get a mark for rearranging it. So m equals 4.5 times 10 to the minus 12 divided by 9. We've just calculated that square. So 3 squared is 9 times 10 to the 16, because that's squared, remember from maths. Okay, and the answer, 5 times 10 to the minus 29 kilograms. And it's already written for us there. So that's just putting numbers into an equation and rearranging it. Really nothing too bad there. Okay, one of my favourite topics. Okay, it's a good one to get asked a question on. Now, you might think it's not a good one, but it is. Nuclear fission is used in nuclear reactors and some power stations. In the reactor, a fission chain reaction is maintained and controlled to produce a supply of energy to generate electricity. Figure 14 is a diagram of a nuclear reactor. Movable rods, so the rods, shield, nuclear fuel, so that's uranium usually, graphite core, and reactor vessel. Coolant comes in, usually water actually coolant there. Let's have a look at the question. Explain how the graphite core and the movable rods are used to maintain and control the chain reaction. So this is going to be assessed on English too. A little star next to it. So the way you write is also giving you a mark as well. So you have to write in full sentences. You can plan in statements, but you have to write in a sentence that makes sense. Okay, so for nuclear, this is nuclear fission, remember? Nuclear fission to occur. So, okay, splitting a uranium nucleus. Okay. Neutrons, okay, have to move slowly. Otherwise, they just bounce off the nucleus to split the uranium. Okay. So we've got a few things. We've got something called a moderator. Okay. And we've got something called control rods. Okay. So let's have a look at the moderator first. So graphite, the moderator, okay, slows down neutrons for this reaction to occur. Okay. Graphite does the moderator doesn't move, it stays in there. You can use other things for moderator. Okay, but graphite is one of them. Okay, slows down neutrons for nuclear fission to occur. Okay, that's what they do. So the control rods, as their name suggests, controls the speed of the reaction. This will give you another mark. I've got quite a few marks already. The control rods control as the speed of the reaction. Of the reaction. Okay, they absorb neutrons. So I didn't write that very well. Reaction. Okay, they absorb neutrons. And the control rods can be moved in or out to control the speed. Okay. Of the reaction. A bit of room. Just have a little bit of room. There's lots of room. Of the reaction. So when a little bit of extra here, make sure we get the marks. When more control rods are in, the reaction is slowed down. The reaction is slowed down. Okay, so that's what we need to write. I'm going to sort of go up a little bit, show you the whole answer. Okay, so that's actually all you need to write for 6 marks. You don't actually need to write, because one of the marks, remember, is for clarity. Okay, and we've got all the points there. So don't worry about writing too much for 6 marks. It has to be concise. Okay, so thank you for listening to that. That's the end of the exam. Okay, total for paper, 100 marks. Thank you for listening. I hope to see you for paper 2, physics and other for other chemistry and biology too. Thank you. Goodbye.